Hi everyone, welcome to the second part of my video series on categorical encoding. In my first part, I explained to you about what is nominal versus ordinal categorical variables, as well as how do you encode, or what do you mean by encoding using label encoding and one-hot encoding. Now I want to talk about target encoding and count encoding. And stay tuned for part 3, which is embedding, categorical embedding, which a lot of you ask me about making a video about that. So that one I want to dedicate a video only for the categorical embedding because it's a new concept, which is used a lot in deep learning and also in natural language processing. All right, so let's talk about target encoding and count encoding. These two also are not really that familiar, I assume, for a lot of audience. So what's the target encoding? This actually is considered as a very strong technique for encoding categorical variable. It's also known as a mean encoding. Some people call it likelihood encoding. So now let's see what that is exactly. Target encoding, target or mean encoding. It means that we're going to go ahead and replace a category by the target, by the average or expected value of the target value appearing in that category. And what we mean by target, so first, what's the explanation of that? Replacing the category, replacing each category, replacing each category by the mean, average, or expected value. They're all the same. Expected value of the target. What is target? What we want to predict. What we want to predict in that category. In that category. All right. So is a way, of course, to represent a categorical variable using a numeric numbers, right? Because machine only understand numeric numbers, right? But what we do here is that we're going to replace each category by the expected value of a target present in that category. I'm going to go over an example, make it very clear for you guys. And that's why the name is coming as a mean encoding. All right. Now, what's the target is what we want to predict in machine learning, right? All right. So let's go over an example, very interesting example here. Let's say we want to predict the price of a house as a function of a state, the state that you're in. In a sense, that's what we have is a data set. It has only two columns. This is the state, and this is the house price. All right. Choose another different color here. We have California. We have New York. We have again California. We have Arizona, and let's say we have again another Arizona here. All right. So these are different states, and the house price here we have 400,000. I just write K 400,000. Here we have, let's say, 500,000. Here we have 600,000. Arizona is in cheaper side, 200K, and then we have 100,000. All right. When you look at the state, you see that a state is a nominal categorical variable. So target encoding is mainly for nominal. I will go ahead and write it down, replacing each category by the it's mainly used for nominal when there is no ordering categorical variable. Nominal categorical, right? All right. So a state is a nominal. There is no order. No one says New York is higher than California or Arizona is higher than New York. All right. So label encoding will not work. Here in this specific case, you can say that, hey, I can use one-hot encoding. But guess what? What if I tell you we have 50 states here? So you want to add 50 columns here? It doesn't really make any sense. Okay. Or what if I want to calculate the house price as a function of city? If you have 1,000 cities, more than 1,000 cities, do you want to add 1,000 very, very sparse representation of the vector, very sparse vector to our data frame? If you haven't watched my first video on categorical encoding, please go ahead and watch that, because over there I'm going to talk about the disadvantage of using one-hot encoding. All right. So what we do during the target encoding or mean encoding is as follows. We're going to go ahead, different color here, and let's say that what I'm going to replace California with. I'm going to replace California with the mean value, average value of the house price, because that's our target within the California. So you see the California, we have two house price, 400K and 600K. So I'm gonna ask myself, hey, what's the average price here? So let's say the California bar is gonna be 400K plus 600K divided by 2. So it's gonna be 500K. And then New York, there is only one. So New York is equal to 500K because it's only one. And Arizona, the average is equal to 200K plus 100K divided by 2 is equal to 150K. So when we go to the new representation, we call this one target encode and house price. So California, anything you see California, just replace the 500, then 500, 500, 150, 150, and then you get the target here as well. As simple as that. That was the target encoding. All right, is this a good math technique? Let's talk about pros and cons. The pros first. Easy to implement. What else? I did this in the past video. I have to use different color for when you're doing this pros, and then all right. Easy to implement. What else? Can relate, can I would say relate or show, or can show the relationship between target and feature directly, which is good, right? It's really good. 3, it does not introduce new dimension. Remember one-hot encoding, add as many columns as the number of categories you have. Here, no, right? So it does not add new dimension or column. All right. So that's really a good thing. So what's the cons then? What's the cons of that? Easy to overfit. Guys, what do you mean by easy to overfit? What is overfitting? In training, you can achieve a very high accuracy. When you go to testing, you get a very bad or very low accuracy, right? Why is this the case? It does not generalize well if a category has a small sample size in our data. All right. Let's take a look at the example of what I mean by that. All right, so let's talk about the income. Let's go ahead over an example here. Let's go ahead look at the income as a function of a city now. Income as a function of city. We have LA, we have LA, we have LA, we have New York City, we have New York City, we have New York City, and then we have here only San Diego. So here I have 200K, here I have 300K, here I have, let's say, 400K. New York, I have, let's say 400K. I'm just making this number up. 400, 500K, 600K. And then SC, I have only, let's say 150K. So if you go with the target encoding, what's going to happen here is that you're going to create a new data frame. You call it target encode income. And then here, LA is going to be the average of these three. So instead of that, the average of these three is going to be 300K. So you're going to replace it in 300K, 300K, 300K. So the average for New York become 500K, 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 and then SC 100K. All right. So, and then the income also we write it as, we just copy it from here. All right. So as you see here, San Diego has only one sample here. Is it okay? Do you think it's right? Is a right thing to generalize San Diego based on only one sample size? Only one sample size appear here. Of course, here I had only 7 rows. In a real machine learning application, you have millions and millions of rows. If a category appear only 10 times, do you think this is really a reasonable assumption to calculate the average value for that? No. So that's why it's easily overfit. It's easily overfit. If the category has a small sample size, this technique is not a good technique. What can you do to combat that? To combat this, you can either use a smoothing, like Laplace smoothing, or oversampling, something like this. So you can combat this problem. Another problem that it has, is it overfit is the main problem. Another problem it has is that the categories with similar average or similar mean target get the same importance. Same importance. All right, so this is very, very important, guys. The categories with similar mean get the same importance. So here, New York and New York City and LA get the same importance. Is this what we want? I'm not sure, not really, right? We want something, the features give some uh, metric to differentiate between the features, but here they get the same importance. So these are the big problems with the target encoding. But depends on your data set, this can be actually very easy way to include it in your problem. And it might work very well. Actually, some people recommend this one as the one of the ideal or one of the best technique for the encoding categorical values. And remember, it's very easy, and it does not add any new dimension. You have 10 categorical values, let's say, right? Each one you're gonna use a target encoding. You're gonna have 10 columns. All right, great. Now let's talk about count encoding, another easy one. Count encoding. All right, so count encoding. During the count encoding, we replace each category by the number of time it appears in the data. As easy as that. All right, there is a frequency encoding as well, that instead of count, you replace it by the frequency that appears in the data. But the count encoding, you're just replacing it by the number of times it appears in the data. As simple as that, right? All right, let's take an example. Let's take an example here. Let's say that we are trying to look at the same example as we had before. Let's see if I can we can copy this one somehow. I guess that's simpler. Yeah, it's simple. All right, this is simpler. Great. Okay, so now if you want to do the count encoding, you're gonna go ahead and here you call it count encode, and this is income. Okay, LA appeared 3 times. 333. New York City appeared 3 times. 333. San Diego once. 200K, 300K, 400K, 500K, 600K, 700K, 150K. All right, so that's the count encoding. How many times it appears in the data? So as simple as that. You can't believe that how popular is this technique actually. So what are the cons and pros? Pros, easy to implement. Second, does not it does not add new dimension. It does not add new column dimension feature, whichever you want to call. All right. So these are the advantage of that. What's the disadvantage of this? What's the cons of that? The cons is that um, categories with the same count get same importance. Is this what we want? Most probably not, right? You can see we don't want the LA, okay, appears more, therefore it should get actually more importance than the San Diego. Doesn't seem to be the case, right? And this is the one of the problem of that. Another one is that all right, so since you look at the problem as again related to the count with the you replace it with the numerical values, if category doesn't appear many times, then it gets a very, very low importance. Category does not appear often, it gets very low importance or impact. So that's also another problem that it has. Okay, so it's totally based on the count of the variable appears. It doesn't also take the meaning into the consideration and so many other things. But this is the two dominant problems that um, the count encoding has. All right, so today we talk about the count encoding and the target encoding. That's it for this video. Next video, I'm going to talk about the categorical embedding. Okay, it's something that a lot of people are looking for that. All right, so if you like this video, please subscribe to the channel, like and share this with your friends. And with that, I see you all in the next video. Thank you so much. Bye.